Hi guys, this is 5.1 angles of triangles. So this is new information and let's go ahead and get started. So first we're going to go ahead and get started with classifying triangles by sides and angles. The two ways we can go ahead and do that. And I'm going to go ahead and describe to you the first three ways by using sides. If we notice with the first way, we see that we have a scalene triangle. And a scalene triangle basically means that all of these sides are not going to be congruent. So there are going to be different measures. Now, if you can't notice it by just the eye, then you can go ahead and measure it with a ruler. But most of the time you'll be able to see it just by looking at it. The next way of classifying a triangle by its sides is by isosceles triangle. And an isosceles triangle is saying that we have two sides that are congruent to each other. The next one that we have is an equilateral triangle. An equilateral triangle is saying that we have all sides that are going to be congruent to each other. Well, let's go ahead and jump into the next way of classifying triangles by angles. Now for angles, with an acute triangle, we're talking about all of these angles have to be less than 90 degrees. That's what makes it an acute triangle. Do they have to be congruent to each other? No, they just have to be less than 90 degrees. The next one is a right triangle. A right triangle only has to have one angle that is 90 degrees. The next one that we have is an obtuse triangle. The obtuse triangle has to have one angle that is more than 90 degrees. That's what makes it an obtuse triangle. And the last classification of angles is an equal angular triangle. An equal angular triangle has to have all three of my angles that are congruent. So you'll notice with equal angular triangle and equilateral triangle, they look very similar, and that's because they are. If it's equilateral, it automatically is equal angular. Why? Because if your sides are all congruent, then automatically all your angles have to be congruent. But if they're asking you to classify the triangle based on sides, then you have to state that it's an equilateral triangle. And if they mark up all the angles that are congruent, you're going to classify it by saying it's equal angular. So vice versa, if all the angles are congruent, then automatically all the sides have to be congruent. Last but not least, that goes to say the same for isosceles triangle. With an isosceles triangle, if you have two sides that are congruent, then you automatically have two angles that are going to be congruent. That's the way our isosceles triangle works. Remember, if they're asking you to classify your triangle by either angles or sides, these are the ways to go ahead and classify them. This new theorem is called triangle angle sum theorem. And so this triangle angle sum theorem is telling us that angle A plus angle B plus angle C is equal to 180. Again, angle A plus angle B plus angle C is equal to 180. This is not the first time that we see 180. This is definitely the second time. So let's go ahead and think back to where we saw that 180 pop up for the very first time. But again, we're talking about a triangle, and a triangle has three sides and three angles. And all of these angles, if we add them up together, they have to equal to 180 degrees. We have to know with our triangle that it comes with interior angles and exterior angles. Now, let's think about what interior means. Interior means that we're talking about angles that are inside something, right? Same thing with exterior. Exterior means that angles that are outside of something. So logically, let's talk about the triangle that we have here. Well, inside of my triangle, the interiors are angle A, B, and angle C. They're inside my triangle. And as you can see, the angle D is outside of this triangle. So angle D is my exterior angle. Okay, so remember we've seen 180 degrees come up somewhere. Now let's talk about that. Where did 180 degrees come up before? Well, you should have remembered that it came up with supplementary angles. If you notice, we do have a pair of supplementary angles in my diagram. Where are they? Well, remember, supplementary angles are two angles that make a straight angle. Also known, another word for that is linear pair. So we're talking about these two angles. So we're talking about angle A plus angle D is equal to 180. This is true because, once again, we have two angles that make a straight angle and are equal to 180. Now, what did we just learn from up above the previous slide? We learned that on the previous slide, we had angle A plus angle B plus angle C is equal to 180. Well, hopefully you notice a couple of things. So I'm going to take this statement and bring it down here. And I'm going to take this statement and bring it down here. Before I do that, let's name this statement though. What do we notice about these two? We should notice that these two statements are equal to the same thing. Well, if they're equal to the same thing, why not just substitute them and make them equal to each other? So that's exactly what I'm going to do. Make them equal to each other. Once we do that, we should notice that both of these statements have angle A. And if I took angle A away from each other, away from them because they're the same, you'll notice that they'll cancel each other out, leaving us with this new statement that says angle D is equal to angle B plus angle C. Now, this new statement is called a triangle exterior angle theorem. It means that our two non-adjacent angles, remember angle B and angle C are not adjacent to angle D. So angle B and angle C are not adjacent, non-adjacent to angle D. The sum of these two angles is going to equal to the exterior angle. That is what our triangle exterior angle theorem is. Basically saying angle B plus angle C is going to equal to my exterior angle, angle D. Now, I didn't define with you what an exterior angle is, and I'll do that really quickly right now. If we go back to that slide, we can see that an exterior angle, which is D, is made by the side of a polygon and the extension of our polygon. So again, the side of a polygon and the extension. So that's what the first definition is here. It's formed by the side of a polygon and an extension of a side. The next definition is remote interior angles, which is basically what we just talked about with angle B plus angle C is equal to angle D. Talking about the two non-adjacent interior angles, those two non-adjacent interior angles are going to equal to, the sum of them is going to equal to the exterior angle. And that's remote interior angles. That's what the definition is, okay? I'll read it for you one time. For each exterior angle of a triangle, it equals to two non-adjacent interior angles. This next thing is important for you to know. Maybe it'll stick with you, but if you also forget it, it's not a huge deal. The reason why it's not a huge deal, because if we know about our triangle sum theorem, we're talking about angle A plus angle B plus angle C is equal to 180. So we just learned that from this lesson, that the three angles of our triangle is equal to 180, right? Well, if that's true, and we know that angle C in this case is equal to 90 degrees, all we got to do is replace this with 90 and then eliminate the 90 to get it the other angles that we don't know about by themselves, and realize that really these two angles, angle A plus angle B, have to equal to 90 degrees. All right. Again, not a big deal if you don't remember it. All right, so I'm going to do this example with you. If we look back at the notes that we just took, we should realize that angle X here, this X variable, is what type of angle? Well, an exterior angle. And according to what we just learned about, that the exterior angle is going to equal to the remote interior angles, right? The two non-adjacent angles. So all I have to do for this problem is say that x is going to equal to the two non-adjacent angles, which are 60 plus 65. And so this angle x, has to equal to 125 degrees. Hopefully that makes sense. So the next example, I'm going to go ahead and let you do this one. So go ahead and pause the video and try it out. Okay, now that you've paused the video, I'm going to go ahead and do the example with you. So once again, going back to the same concept that we just did right now, we're going to go ahead and say that P is equal to the two non-adjacent angles. What are they? 46 plus, well, what's this angle here? You should know it as 90 degrees. So P is going to equal to 136 degrees. All right. This next example is not any different than the first two examples that we just did right now. The only difference is now we actually have a couple more variables. So you got to do the same concept. Remember, we're doing the exterior angle is equal to the two non-adjacent angles, the sum of the two non-adjacent angles. So that's what we're going to do for this example. So I'm going to go ahead and let you do this on your own, and I would like you to go ahead and press pause now. So remember, which is the exterior angle in this case? The exterior angle is angle PQS. If you don't remember, we're talking about this angle, angle PQS, this angle right here. So angle PQS has to equal to the the two non-adjacent angles, which in this case are angle R plus angle S. The two non-adjacent, remember this is the adjacent angle, and these are the two non-adjacent ones, right? And so, based off this, I can go ahead and write that 3x plus 25 is equal to 2x plus 65. If you don't remember what to do, remember me personally, I like to have my variables positive, so that's the first thing I move. Subtract my 2x's from both sides. I'm left with x because 3x minus 2x is going to be x. Plus 25 is equal to, and 2x minus 2x is just 0, so we're left with on this side 65. And finally, to get my x by itself, I am simply going to go ahead and subtract by 25 from both sides. And x is equal to 40. This next example is definitely a tough one. So what I'm going to do is I'm going to do a couple with you, and then I'm going to let you do one by yourself. Depending on how you see this is up to you and how you want to go ahead and start. So you can start with A, you can start with B, you can start with C. The one that pops out to me is C. I'm just going to start with C because I'm going to focus on the triangle on the right side. Let's quickly talk about that. You should see a total of 3 triangles. We have triangle 1, which is the blue one, triangle 2, which is the green one, and last but not least, the large triangle. All 3 of these triangles can help you find different information. So depending on what you see first and what you find easiest is the variable you should find first. But for me, I automatically see C and say, oh, I can find C right now. Why? What can I do to find C? Well, I can take 53 and C and 44 and add them all together. So C plus 44 plus 53, what are they all going to equal to? They're all going to equal to 180. How do I know this is true? Because I know that in our triangle that all 3 angles, if you add them all up, they're going to equal to 180. So let's add that up. And so if I simply subtract 97 from both sides to get C by itself, I'll get that C is equal to 83 degrees. Now, me personally, what I like to do with all of this information is once I find an angle, I put it back on my diagram because it might help me find another piece of information. And sure enough, I see something differently that you might see. And so what I'm going to go ahead and do is find B at this point. If you don't see it, that's okay. I'm going to find B by using my supplementary angles. So I see that angle B plus C is equal to 180. I know what C is. I just found it. C is 83 degrees. So all I have to do is subtract that information to find B. And B is equal to 97 degrees. So I found A and B for you. Sorry, I found B and C for you. I want you to go ahead and pause the video and find A. All right, now that you've paused the video, there are so many ways that you can do all of these different variables. It's totally up to you on how you choose to do them. So for A, what I'm going to do for A is use my smaller triangle, this triangle here. And what I forgot to do for you guys when I was doing the problem is put B back on the diagram. So B is 97 degrees, right? So all I'm going to do is use the red triangle. So A plus B plus 28 is equal to 180. I know what B is. I know that B is 97 degrees. So I'm just going to plug that in. And finally, find what A is. And add this information. And subtract that to get my A by itself. And A is equal to 55 degrees. All right. So there it is, A, B, C. All right. Let's go ahead and move on to this last example. And this last example, I'm going to let you do it all on your own. Before I let you do that though, I need you to know that you need to find angle 3, angle 4, and angle 5. Now what should you do? Maybe you should focus on one angle at a time. Which angle? I'd say probably go with the triangle that has the most information. So at this point, I'm going to go ahead and let you press pause so you can do the problem. Okay, now that you've pressed pause, we're going to go ahead and get started. The first angle that I'm going to do is find angle 3. How do I know? Because this triangle over here on this side has the most information for me to work with. What do I mean? I'm talking about that it has this angle and this angle here too. And what do I know about that triangle? I know that a triangle is equal to 180 degrees. So I'm going to take all three of the angles and add them up and equal to 180. So 72 plus 86 plus angle 3 is equal to 180. Add these up. And so I have 158 plus angle 3 is equal to 180. Once I do that, subtract it to get angle 3 by itself and is equal to 22 degrees. Now that I know that, put the information in the diagram. I know that angle 3 is equal to 22 degrees. Because I know that, you should hopefully see that these two angles, what are they? They're vertical angles. And so angle 4 also has to equal to 22 degrees. And because of that information we just discovered, we can say that 22 plus 70 plus angle 5 is all equal to 180 degrees. Why is this true? Because we have another triangle. And so we add those two up, subtract 92 from both sides, and angle 5 is now equal to 88 degrees. And we're done. Thank you guys.